So let's do some examples of the limiting reactants in our unit for chemical reactions and quantities. So first example that we have here is that we have acetylene reacts with oxygen to form how much carbon dioxide. Now this is a chemical reaction that I usually require most, if not all, my students to memorize, and because it's a combustion reaction, and all combustion reactions give us very predictable outcomes, and therefore that's why I want our students to be able to predict that. Well, acetylene C2H2 is going to react with oxygen, meaning it's going to be burned in air, and therefore we know it's also going to make carbon dioxide. The other product of that is going to be water, or H2O. So now I have that given to me, I can now balance my chemical reaction. Being is that I do have to balance out some things first here. We need to be able to kind of see what's going on with that. And I'll have to balance out my hydrogen looks to be good. My oxygen is going to definitely require some help, but we should be able to kind of go with that. Well, I'm just going to go through and balance. So if I put a 2 there, that should balance out the number of carbon, and my hydrogen already balanced. However, I do see that my oxygen are 5 total over here and just 2. Well, that doesn't match out really nicely. So how do I do that? Well, I can see where my problem is, and that is over in that water molecule. Or I can use the little trick that I've used before, and that is utilizing the fact that if I multiply everything by, if I needed 2.5 and I multiplied everything by 2, well, that would mean I need a 2 in front of my acetylene. I would need 5 there. I had a 2 in front of my carbon dioxide, which now means that I need a 4 there, and then I would also need a 2 there. And therefore I should have my chemical reaction completely balanced. Now, when we look at limiting reactant problems, a lot of us are going to look at and say, hey, I have 2 givens, and now my carbon dioxide, how much? Now, let's go simple and just convert how much and we'll say, let's just say how many moles of carbon dioxide to give us that. So now that I have that, my limiting reactant problem becomes which one is which. And so from there, I might predict and say, well, acetylene obviously is my smaller amount, so therefore it's my limiting reactant. But is it? We don't know yet, and that's what limiting reactant problems do. So I'm going to resize this, and now I have kind of 2 sides to work with. And when I do that, to find the molar mass of acetylene, I will find it on one side. And to find the molar mass of oxygen, I will do that on the other side as well. So for acetylene, I have 2 hydrogen, I have 2, multiplying that by 1.01 and 12.01 to give me 24.02 and 2.02, and add those up. Now, what I've done so far is actually nothing new. Everything I've done so far on that one is exactly the same. So for oxygen on the other side, I'm going to have 2 times 15.99 to give me 31.98 grams per mole. Again, not having done anything different than I've done before. Well, here becomes the difference. And so here, I'm going to convert 20 grams of acetylene, and this is why labels are so important, to make sure we know which one we're converting and which one we're not, into moles of acetylene. And using, again, the molar mass that I calculated just now. At the same time, I can also calculate out the moles of oxygen given the amount of grams of oxygen, again, at the same time. Now, I'm going to split these kind of here to kind of help me visually split them. And whatever you have to do, some people will write them side by side. I tend to do top and bottom. And again, it's just a personal preference that you need to use to kind of go through this process. And so when we look at this, and I'll go grams of oxygen, I can do my calculations to calculate the number of moles as I need to, as I would kind of have the number of moles of acetylene is 0.77 roughly, and that's acetylene. And then I have a little bit over 1 moles, 1.6 moles of oxygen. Now, there are some problems that I've seen in the past where I've seen reference material take this and convert it into moles of oxygen, and I've seen this convert that into moles of acetylene, both at the same time again, and then you do your comparison. I don't like that. I find then you start kind of second guessing, like, and confusing your numbers up a little bit. My suggestion to students is usually always been finding one of these and do your comparison with just one of them. So I'm going to convert this. This is the smaller number. So I'm saying acetylene might be my limiting reactant. And so what I'm going to do is I'm now going to use that stoichiometric ratio and do my comparison of moles of acetylene to moles of oxygen. And I'm going to see something very interesting here, in that I actually am going to have 1.93 moles of oxygen. So now here it shows that if I react 20 grams of acetylene, I need 1.93 moles of oxygen. This is how much oxygen I have in moles. I do not have enough. One of these is smaller. That's this one. And therefore, oxygen is actually my limiting reactant. Oxygen is going to limit the amount of carbon dioxide that I'm going to produce. And by doing it this way, I think, personally for me, that it's easier to see that one number is smaller than the other than trying to convert and then trying to and be confused with what numbers are you comparing to what numbers over on the other side. Convert one thing to the other and you're usually going to be good. Now, there are other chemistry teachers out there that are going to teach this differently. There's going to be other reference materials that are going to teach this differently. This is what works for me, and this is what I have found works for most of the students. You have to, if this is confusing, you're going to have to figure out which route to take. And then I can help you along, but this is what I use, and therefore it works for me. If this is confusing and you want to try and find another one, we can try to go through that process, but I think this one works the best. And since in the problem I changed to how many moles of carbon dioxide, I can actually just go through that whole process and just say, you know what, I'm going to convert this one to moles of carbon dioxide. Now, why again am I using this one? That's because oxygen is my limiting reactant. And therefore, that's the one we have to use to go forward in getting my answer. And with that, I can see, using my molar ratio, and going from there, my 1.6 times 4, and divide that by 5, and I'm going to get about 1.3 moles of carbon dioxide. So let's try another one out. If I have 30 grams of silver nitrate and that reacts with 50 grams of sodium chloride, how many grams of silver chloride will be produced? Well, the chemical reaction that we're given, actually in all reality, actually are given, is balanced out for us. And so my givens are 30 grams of silver nitrate and 50 grams of sodium chloride. My want is grams of silver chloride. And so I have to go through this process of, again, finding my limiting reactant, which one of these is going to limit the production of silver chloride. So now I have to go through, I'm going to resize this here and go through the same process as before, as I've done in the past. And I'll have my sodium chloride over here and my silver nitrate over here. I will put my silver chloride in the middle here. I think that is going to be important. Since they're all 1-to-1, I should be able to kind of make my life a little bit easier, and just kind of do some basic look on my periodic table to find silver being 107.89 and 35.45. Add those together to get my answer of my want. I'm going to need it because I need grams of my want in this case. And that's going to give me a value there of 143.34. Now again, these can be very long and lengthy because there's a lot of things that you have to find and making sure that you put them in the right place. And so here I have silver, nitrogen, and oxygen. Oxygen is 3 and 1 and 1. 15.99. 14.01. And I just calculated of 107.89. 107.89. 14.01. And then going through that whole process, 15.99 times 3 to give me 47.97. Add that all up. Give me 169.87 grams per mole. Sodium chloride, 22.99, 35.45. Add that all up together, and I will have my, I believe, 58.44. Now, just like before, we are going to calculate two knowns at the same time. And in doing so, I'm going to kind of split them up to kind of see which one is my limiting reactant. Because I don't know at this time. I might look at this and say, that's silver nitrate. That might be the one. Or I might look at it and say, well, the bigger one last time was it, so how am I supposed to know? And so we don't know. And that's why we have to do our calculations of these, and so we can find out which one it is, because there's so many things that might lead us astray and make us think one or the other. And so what I'm going to do again is just convert to moles of each substance. And how I do that, again, using the molar mass. And again, why labeling is so important, so I know what I'm using, as that is going to benefit me in trying when I'm have numbers with my labels, and kind of see where I'm looking at some of this stuff at. And so now I can do some calculations. I'm going to say 856 moles sodium chloride, and then 30 divided by 169.87 gives me 0.177 moles of silver nitrate. Silver nitrate. Now this one, because it's 1-to-1, is essentially solved for us. The silver nitrate is going to limit my production because it has a smaller number here. If I convert this using the balanced chemical reaction, it's going to give me the same number of this. And if I do that, and let's do that anyway, just for the sake of examples, 1 mole, where am I getting that from, is my balanced chemical reaction of silver nitrate. Make sure I write out the problem correctly. 1 mole of silver nitrate to 1 mole of sodium chloride, and that's going to give me 0.177 moles of sodium chloride. Now, which number's smaller? That number, or that number. Now, they're both small, but this number is smaller, which means my limiting reactant is my silver nitrate. Now, what's nice about this is that I can take and utilize the rest of this problem using just this here. Now, do I use this number or do I use this number? It actually does not matter which number I use. So I'm going to write that this one's bigger, therefore it's in excess. So I'm going to take and convert my silver nitrate and kind of splitting that off. Now I'm going to convert that into my silver chloride utilizing my balanced chemical reaction. So 1 mole of silver nitrate and 1 mole of silver chloride from the balanced chemical reaction. I then convert that into my grams of silver chloride utilizing my molar mass of my want that I have already calculated, and therefore it should be pretty straightforward of a multiplication to give me the fact that I will calculate out 25.31 grams of silver chloride. And there you have it, a full limiting reactant problem. And again, sometimes you can kind of guesstimate some stuff, but sometimes you can't. So kind of looking for every little bit to kind of help in writing your notes of which one's in excess can sometimes help identify, don't use that number, and or use this number. Now, hopefully that helps some things out.